All right, in the first part of 1-6, we're going to be looking at compound inequalities. So if you think of what compound means, think of like a compound sentence, which is two sentences joined together, or a compound word, which is two words joined together. So a compound inequality is two inequalities joined together. So a compound sentence, you join them together with a word like and, or, but, you've got all sorts of options. With a compound inequality, they are also combined by words like or and. Those are the only ones we use. So we're going to start with the and inequalities. So and is a combination of the two. It ends up being basically the overlap. So let me give you that in symbols. So and inequalities will look like this. I'm going to use number lines so you can start to see exactly what I mean by the overlap. So and compound inequalities are true if and only if both inequalities are true. Okay, so again, let me show you what I mean by that. So start with this one. X is greater than or equal to -4. So let's draw that. So we got a number line. Here's the 0 just to give us a sense of where we're at. So -4 could be somewhere like right there. So if we have greater than or equal to a -4, that would look something like this. So greater than or equal to means it would be shaded and shaded off to the right. So that's our greater than or equal to. Okay, so that's just that one inequality. Now let's look at less than 3. So same thing, let's line this number line right up underneath it so we can keep the same scale, 0 in the same place, and then the 3 would be like right around there. Okay, so less than 3 would mean that you're gonna have it open and then shaded off to the left. Okay, so there's that one. All right, so now when we say greater than or equal to 4 and less than 3, what that means is we're going to combine them. We're going to look for both inequalities being true, and that means we're going to look for the overlap. So picture, I purposely shaded them in different colors so you could see what I mean. This one's green, this one's orange. If I were to overlap them, what it means to be and is where you'd see the green and the orange physically overlapping each other. Okay, so that happens here. Again, the 0 just for reference. So here's the -4 and here's the 3. So the overlap between them would be like in between these two lines right here. They overlap. This part's just orange, so it's not in the overlap. This part's just green, so it's not in the overlap. But the overlap would be in between these two pieces right here. So in between the -4 and the 3, including the -4, but not including the 3. Okay, because the -4 itself is part of the overlap, but the 3 is not because it's not included in this set. Okay, so we go from -4 to +3, again, including the -4, but not including the 3. So we've got a closed circle for the -4, open for the 3, and then everything in between would be part of our shaded region. So that would be the final answer. That's what it means to be and. That's our first of the compound inequalities. We also have an alternate form that we can write, and this is a 3-piece inequality. You're going to see this a lot. The alternate form looks like this. Okay, so you can see a 3-piece inequality, and it literally looks like this. -4 is less than all the x values, which are like the shaded values, which are less than 3. So you say -4 is the smallest possible of all the x values, and 3 is the largest of all the possible x values. And that means everything in between is shaded. Notice this has an or equal to, which means the -4 is shaded. This does not, which means the 3 is not. So that is another way, and like I said, we'll see that a lot, so it's really important that you start to get comfortable with that. Okay, so let's solve this one. So this is a 3-piece inequality, just like the one that I wrote right here. So we're going to solve that inequality. Okay, so 10 is less than or equal to 3y minus 2, which is less than 19. So what we're going to do is we're going to solve for the y, and when it's a 3-piece inequality, when we solve for the variable, we want to get the variable in the middle. Okay, so to get the variable in the middle, we're going to start by adding 2, and instead of adding it to both sides, you add it to all 3 pieces, since it's a 3-piece inequality. So add it to the 10, add it to the 19. So it cancels here. So 10 and 2, I have 12. And I still have the 3y left in the middle. And then 19 and 2 is 21. So now again, dividing by 3, trying to get the y by itself. So if I divide this by 3, then it means that I have to divide every piece of the inequality by 3. So in the middle, the 3's will cancel, and the y will end up by itself, which is exactly what I was trying to do. And then I have 12 divided by 3, which is 4. Keep the sign. Now y is by itself. And then 21 divided by 3 is 7. So this is your inequality. So this would be the answer. And remember, like we were talking about up here, what this means is that my shaded region is going to be in between these two numbers. Okay, so you can kind of read it like forward and backward. You can read this as like x is greater than or equal to -4 and x is less than 3. So this would be like y is greater than or equal to 4 and y is less than 7. But it's easier just to remember, like, see how the y is literally written in between these two numbers? That should help you to remember that we're literally shading in between those two values. So when we go to set them up on a number line, and here's 0 for reference, so 4 would be, here, and 7 would be here. So 4, see how this has the less than or equal to? That means the 4 is getting shaded, and then the 7 would not be because this is open. So shaded here, open here, and then we are shading in between those two values. So that's what the 3-piece inequality like that means. Okay, so that's the and. Let's look at what it means to be an or inequality. So an or inequality is true if one or more inequalities is true. So either or. This one or that one or both. Maybe there's overlap, but literally one or the other. Okay, so it's true if one or more inequalities is true. Okay, so if one of them is true, then the or would be shaded. So let's do the same sort of setup that we did up here, where I start to overlap them and show you exactly what this means. So x is greater than or equal to 5, so we're going to line up number line. Here's 0, the 5 would be there. So greater than or equal to 5 would look like this. Shaded, because we have the or equal to, and then greater than would go off to the right. Okay, so that's the first one. And then I have less than -3. So I'm going to line up an identical number line underneath, so the scale is right. And then -3 would be around there. Less than -3. Less than means I would have an open circle. Less than means that I would shade the region off to the left. So notice with this one, there's no overlap. It's fine if there is, but with this one, there just doesn't happen to be any overlap. So when we say or, it means one or more. So when I say this or this, that means it can fall into this one, it can fall into this one, it can fall into both. Basically with an or, you just combine all of them all together on one number line. Okay, so our final result will look like this. Okay, so we're literally just combining them onto one number line. So here's this one, here's this one. And that would be your final answer, is you would have these two separate pieces going off in opposite directions. Okay, so when you say or means you graph both of the solutions on the same number line, and that would be your final answer. So let's solve these. For both of them, we want to get the x by itself. So I gave you just some kind of simple ones just so we get used to the idea. So here we're going to subtract 3 from both sides, and then x would be by itself. Less than 2 minus 3, which is -1. Or, and then this one, all you'd have to do is divide out the negative. So divide both sides by -1. Be super careful. Remember with inequalities, if you divide both sides by a negative, make sure you flip the inequality symbol. So keep the or. The x would be by itself. Now instead of being less than or equal to, this now becomes greater than or equal to, because I divided by a negative, and when I divide by a negative, I flip the sign. And then -4 divided by -1 is +4. So this is what I'm graphing. Graph on a number line, that means put this one on a number line, put this one on the same number line. If they overlap, great. If they go off in opposite directions, great. Or just means that you are putting them down together on one number line. Okay, so 0 in the middle. Here's the -1. Here's the 4. Okay, so less than -1 means that you would have an open circle on the -1. And then it would go off to the left. And then this one, greater than or equal to 4, greater than or equal to would be a shaded circle. and then I would shade off to the right. So that would be your region. So usually, not every time, but usually with the ors, you end up with two different pieces going off in opposite directions. Okay, so that's it for the first half of 1/6.